1.3. So our title for today is 1.3 continued. Okay, and with your yellow sheet of paper, we are going to fold that in half. We are not going to cut it yet. We're going to fill it out first. Okay, and don't glue it in yet because we're going to fill it out first. And then I'll give you all those instructions. So the first thing we're going to talk about is the angle addition postulate. And our definition is, if you have a point K that's in the interior of an angle, then the measure of HIK plus the measure of KIL equals the measure of angle HIJ. So let's go ahead and let's trace that out just to get a better picture of what's happening. So K has to be in the interior. We talked yesterday how if it's interior, that it's inside the angle. So if I'm tracing this with my finger, I have HIK plus KIJ is equal to HIJ. So another way that you can think of this, we're going to give these some labels. So let's label this one angle 1. And we will label this angle angle 2. So another way you can think of this, it's just the measure of angle 1 plus the measure of angle 2 equals the measure of angle I, which makes sense. If you have two adjacent angles, and so adjacent means right next to, when you have these two angles that are right next to each other, if you add 1 to 2, you're going to get that large angle. And again, this is called the angle addition postulate. It's very similar to the segment addition postulate that we had, but now we are looking at the relationship with angles. Alright, so we're going to go to example 1. For example 1, it says, if the measure of AOC equals 70, the measure of AOB is 1/2 times 2x plus 20, and the measure of BOC equals x, find, and then there's all these things you have to find. So whenever I'm giving this information, the first thing I want to do is see if I can simplify anything. We've looked at quite a few where we have to use what property? Distributive to simplify, okay? So we're going to distribute the 1/2 and we're just going to rewrite that. Yeah, go ahead. Okay, so if you do 1/2 times 2x, you're going to get x. 1/2 times 20, you're going to get 10. And then so this would just be x plus 10 degrees. Okay, and then after that, what I would do is I would label where those are in my diagram. So I want you to just take a second now, and I want you to label whatever angles they give you. So right on your diagram. Okay, so if the measure of, start with AOB. So if the measure of AOB is x plus 10, think about where you're going to put that. Just label your angles. So if you know that AOB is x plus 10, what I would just do is I would just label this as x plus 10. If I know that BOC is x, I'm just going to label this here as x. Okay, and then this is degrees, this is degrees. Now the whole angle is 70, so the way that I would label that is I would just draw from one line to the other line, that whole thing is going to be 70 degrees. So once you have it labeled, now you can set up an equation. So we're going to use the angle addition postulate. The measure of our first angle, which is AOB, plus the measure of BOC. Danny, can you tell me what angle that's going to equal?
Angle AOC.
Good. So that will equal the measure of AOC. And now I can just substitute. So AOB is x plus 10. I'm going to keep my plus here. BOC is x. AOC is 70. The toughest part is setting up the equation. Once you have the equation set up, you're just using algebra. Okay? So we're going to combine our like terms. X and x will be 2x plus 10. And once we have the equation set up, feel free to work ahead of me, because I know a lot of you are comfortable solving equations. So then once you subtract 10 from each side, you need to divide by 2. Your x value will be 30. And that's the first thing I had to find, so I'm going to go ahead and put that on my line. Once you know what x is, we're going to use substitution again to find our angle measures. So the first one is BOC. Well, the measure of BOC is just x. So if I just plug in x, I'm going to get 30 degrees. When you see this M here, that means measure. So this is the measure of angle BOC. Whenever you have a measure of an angle, you have to put your degree sign. So you're measuring in degrees. Yeah, Grace?
I'm just confused. Where did you get the 2?
Right here for the 2x. Yep, so what I did is I combined my like terms. So you have one x here and then 1x there. So that'll make your 2x. Thanks for asking. Do you guys have other questions for me up to this point? Okay, then the next thing we're going to find is AOB. So the measure of AOB is equivalent to x plus 10. So if I plug in 30, I'll have 30 plus 10, which of course would be 40. So then that is going to be my angle measure. And then just double check. You know this is 70, 30 plus 40. Yep, that's going to be 70. Okay, so that answer makes sense according to our information. All right, after that, we're going to talk about an angle bisector. We've already talked about a segment bisector. Does anybody remember what a segment bisector does? That word bisect, what does bisect mean? Yeah, Grace? Cuts it in half, right? So when you cut it in half, you're making 2 equal parts. And we did that with segments last week, or earlier this week. And then today we're going to talk about what happens when you have the angle. So the definition of an angle bisector, it's a ray that divides an angle into 2 congruent angles. And so I'm going to take my highlighter. You can also just underline, but the 2 congruent angles is going to be important. So you can either highlight or underline that. And then whenever I know that the angles are congruent, what we're going to do is mark them off in our diagram. So in our diagram, it tells us if you have XZ, that ray, if that ray is an angle bisector, name the 2 congruent angles that it forms. Okay, so this is an angle bisector of the angle WXY. So with this one, I might even do my picture first, so I can see that XZ is cutting this in half. Yesterday we talked about how you can see from a diagram that they're congruent. They'll have the same number of arc lines on there. And then we would say that angle WXZ is congruent to angle ZXY. Okay, And again, just remember that those names are interchangeable. Okay, so whenever you're given a problem, the first thing you want to do is read through it and then see if there's anything you can simplify. So this tells us that FG bisects angle EFH. What you should do when you read that statement is look at your diagram and just see what's happening. So sometimes I'll highlight just to emphasize, oh, if FG bisects EFH, right, here's my bisector, here's my angle. Once I know that there's a bisector, that means you have to have two congruent angles. So I'm going to go ahead and mark those in my diagram, my two congruent angles. Okay, and you should do the same. I'm going to let you read the rest of this statement. I want you to simplify anything that needs to be simplified, and then I want you to label the parts in the diagram. Okay, so simplify and then label. I'm putting something on your desk, don't touch it yet. Alright, do we need any more time to get those labeled? Okay, so when you simplified, Kaden, what did you get?
5x minus 10.
Good, okay, so we distribute the 1/2, so we get 5x minus 10. Okay, and then that's GFH, so GFH is going to be 5x minus 10 degrees. And then here we have 3x plus 25 degrees. Now we have to find x, so we have to think about what type of equation that we're going to set up. It's not going to be the same type of equation as last time, even though it is true that EFG plus GFH is equal to EFH. But do we know what that big angle measure is? No. What we do know is those are congruent. And when two things are congruent, what do we know about their measures? They're the same. So the measure of EFG has to be equal to the measure of GFH. If they're congruent, they have to be the same. So when we're setting up an equation, what we're going to do now is we're going to set those two values equal to each other. Okay, so we're going to set 3x plus 25 equal to 5x minus 10. So the first thing we're going to do is solve for x. I'm going to give you a minute to do that. Once you solve and you get x, just quietly check with your algebra partner and see if they got the same thing for x. And you can use your calculators. In fact, you're probably going to want to for this one. Check your work, okay. It looks like well, you solved for x here, but why didn't you put that there? Okay, yeah, that's correct for x. If you need some help solving equations, just remember that your goal is to get all of your variables together. So the 3x and 5x have to be on the same side. I always subtract the smaller one from each side, so I have a positive. So if I subtract 3x, I will end up with 2x on the right, which means I have to move any numbers to the other side. And now I'm dividing by 2. Whenever you're cutting something in half, if it's an odd number, you can just think of the even number. So 34, do you guys know what half of 34 is?
17.
Good, so then it would just be 17.5. Okay, so x is going to be 17.5. Okay, for the measure of GFH, now that you know what x is, you're just going to use what to find that measure? Yeah, you're just going to plug it in, right? So substitution. So if GFH is 5x minus 10, you're going to plug in 17.5. Okay, so go ahead and calculate that. Okay, so when you do 5 times 17.5 minus 10, what do we get? Good, 77.5. Now, for the next one, and remember that's an angle, so we're going to put degree. For the next one, EFG, we could do substitution again. We could do 3 times 17.5 plus 25. And I would do that if I were taking like a quiz or a test just to make sure that I didn't make any errors in the one above it. But remember that these two angles are what? They're the same. They're congruent, right? So if this is 77.5, doesn't this have to be 77.5 too? Yeah. Okay, so those should be the same. Now we're going to find the measure of EFH. Well, if this angle is 77.5 and this angle is 77.5, I can use the angle addition postulate because the measure of EFH is just going to be 77.5 plus itself, or you could just multiply by 2 and you would get what? Good, 155. How are you guys feeling about the next one? Good. Okay, so we're trying to find the angle of IFE, which is this angle here, and I'm going to mark this with 2 arcs because it is not congruent to the other 2. But can you guys see that between all 3 of these angles, that makes what kind of angle? A straight angle. So then all I have to do is subtract. So to find the measure of IFE, a straight angle is 180. So I can just do 180 minus 155, and you'll get 25. Good. Okay. Don't glue that in yet. I want you to get the second sheet of paper that I gave you that has the examples on it. Okay, and then I'm going to draw the pictures for you for the first 2, and then I want you to solve them on your own. Okay, so I'm going to give you the pictures, and then you're going to solve them. And if you're really quick at solving them, then you can go on to the next 2, because whatever you don't finish from that will be part of your homework. So if you are getting through it quickly, you can go ahead and keep going. All right, so the picture for the first one, and for these 2, your picture would be given to you. That's why I am drawing them for you. The other 2, you're going to draw your own picture. Okay, so here's your picture for the first one. And then for the second one, this angle is X, WZ, and this is Y. Okay, so I'm going to give you some time right now to finish those two. Okay, so we just talked about some strategies about how to solve problems, and the main thing we did in both of those two examples was labeling. So if you aren't sure what to do, at the very least you got to label. That's something pretty simple that we can all figure out. Okay, and I'm going to go through the first one with you just to make sure you guys have that down. So ABD is 37, so what I would do is label this as 37 degrees. And then the next angle they give you is ABC. So remember to label that, we just draw the arrow to show that that whole thing is 84 degrees. So then what you have to find is DBC. Okay, so we're trying to find this angle here. And we don't know if they're congruent or yet. Okay, they could be, we're not sure. Well, if the whole angle is 84, in order to find the missing angle, what do we have to do? Subtract, right? So we just have to do 84 minus 37. And you can think of it as 14 minus 7 is 7. And then you'd borrow 1 from here. 7 minus 3 is 4. So the measure of DBC is 47 degrees. Okay. All right, and then we will check the rest of them next time we are together. And then we are going to go back to our interactive notebook. And we are going to glue this in. So we're going to cut on our dashed line here. So we already wrote the title for this page. The title was the 1.3 continued. So when I do this, I'm going to put like my glue dots here, 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 here. And then I usually do like a box and then a squiggle there. And then I'm going to just press that down to make sure that's in there. Okay, and then that's your front page for 1.3 continued. And then when you're ready, you're going to flip that page over, and then this is going to go on the back. Okay, so not a new page, you're just going to flip it over, it's going to go right on the back. Okay, and then on the title line for the back page, you're going to call it Constructing an Angle Bisector. And then you can write step 1. Don't do step 1 yet because there's a special place I'm going to have you put the angle. Okay, so don't do step 1. You're just writing down what it is first. So write down your title too, what we're doing. So the next thing that we're going to do is construct an angle bisector. And that's why I gave you the orange compass. Guys, you gotta stay with me. When you're constructing the angle bisector, the first thing we are gonna do is draw an angle. We are going to draw an acute angle, but we're gonna draw it towards the bottom of the page because we are going to need room to use our compass. So what I would do is I would go on your page halfway. Okay, so go halfway, and then you're going to draw just an acute angle. And really, if you put it here. So you can use the straight edge of the compass to draw an acute angle. Don't make it too big or too small. Nope, the measure of it doesn't matter. We're just anything that's acute. So anything that's less than 90. Okay, and then at the top you have your constructing an angle bisector. You have step 1, which is draw an angle. And then for the rest of the steps, what I'm going to do is we're going to write it down first. Then I'm going to do it and you're going to watch. And then I'm going to tell you how to do it again, and then you're going to actually do it yourself at that time. Okay, so for step 2, so this is going right under step 1, you are going to put the center of the circle of the compass. So put the center of the circle of the compass at the vertex of the angle. So remember, that's my angle symbol. then draw a line that intersects both sides of the angle. So put the center of the circle of the compass at the vertex of the angle, then draw a line that intersects both sides of the angle. Okay, put the center of the circle of the compass at the vertex of the angle, then draw a line that intersects both sides of the angle. Okay, so you're just gonna watch me, and then don't worry, I'll say exactly what I'm doing again while you're doing it, okay? So when I say you're putting the center of the circle of the compass, it's gonna be this gold part here, and then this is the vertex of my angle. So what I do is I position that here, and then you'll notice, again, you should not be doing this on your paper, you're only watching me. You are going to choose which number hole you want. I just use 1, 2, 3. And then when you draw the line, you're just gonna go down and then you're gonna go up. And you just have to make sure that it intersects both sides. So like here's an intersection and here's an intersection. Okay, I'm just gonna label that intersection. You don't have to do that. You don't have to label it. Okay, so now what you're gonna do is you're gonna take your compass. You are gonna position that gold ring so it's at the vertex of your angle. And then you wanna hold that with your finger. So you're doing it with me now. Okay, and then what you're gonna do is count. So 1, 2, 3. If your angle is bigger and you need to go more out, that's fine. So then you're gonna put your pencil straight up, and then you're just going to go down, and then you're gonna go up. And that's why you have to hold your finger right in the middle there. Okay, so Alex, that's not how we use it. And if you're not gonna use it to do this, then I'm taking it away from you. Sharpen it, or thank you, Kiss. Okay, so the next thing that we're gonna do, this is step 3. There's only 4 steps, just so you know. So for step 3, you are going to put the center of the compass at both intersections. And you're going to draw lines. Not draws. And draw lines. And those should overlap. Oh, sorry. Okay, so step 3, you're going to put the center of the compass at both intersections. So put the center of the compass at both intersections. And draw lines. These should overlap. Okay, so again, you're going to watch me first, and then I'm going to walk you through it as you do it yourself. Okay, so when I say put the center of the compass, again, I'm talking about this gold ring. The intersections are going to be these 2 points. So at the first point, whatever number you used before, just stick with that number. So I'm going to stick with 3, and then I'm going to go up and down, and then I'm going to do the same thing at the other one. Again, you want to use that same number, but you have to make sure that they intersect. Okay, so you might have to go a little bit more or a little bit less, just depending on what your shape looks like. Okay, so I'll walk you through it one more time. So you're going to put the gold ring at the point of intersection. So the point where the line you just drew meets the side, you're going to hold your finger on that gold line. You're going to count to whichever hole you want to use. And then when you're holding that, you're just going to go down and then up. And then you do the same thing at the other intersection. So the gold line goes here. You're going to count the same number of spaces. And then you want to make sure that those overlap. What you can do is you can just draw a point at that point of intersection. That's going to be a really important part for our last step, which you can see I ran out of space here, so I'm just going to put step 4 underneath it. You might have to do that too. Okay, so step 4 is to find the point of intersection. If you were following along with me, that's what we just did when I marked that point of intersection here. So find the point of intersection of the lines from step 3. Okay, find the point of intersection of the lines from point 3. Then what we're going to do is draw a line. So draw a line from the vertex to this point to construct the angle bisector, which is what we're doing. Okay, so we're going to find the point of intersection of the lines from step 3. We're going to draw a line from the vertex to this point to construct the angle bisector. Okay, so then what I'm going to do here is I am going to draw that line. Okay, so notice how I'm going from the vertex to that point. And then that is my angle bisector. So this that I just drew is the angle bisector.
Fancy.
Okay, so again, you're going from the vertex to that point of intersection. Okay, so when we do the different angles, we'll do those in class. That's why I had you write down your steps. Okay, if you have that on like a test or a quiz, then I would give you those so that you would have them. And then what I want you to do is you are going to draw an angle bisector for an obtuse angle. So we just did one for an acute angle. We're going to do one for an obtuse angle. Okay, so you can draw any sort of obtuse angle. Okay, and then I'm also